Okay, in this tutorial, we're going to look at Kirchhoff's laws, okay, or really Kirchhoff's rules, as they're called, for complex circuits, okay? And Kirchhoff's rules apply ubiquitously to any circuit, but they're particularly useful where the general rules of series and parallel circuits aren't good enough. And this occurs in a lot of different types of circuitry, but when general rules for series and parallel aren't applicable and you have multiple loops, okay? And the whole issue behind Kirchhoff's rules is that you can determine, okay, using the math that Kirchhoff's rules gives you, you can mathematically predict what the current will be in each branch. Now, in this particular circuit, we've got three branches. Okay, so it may be a little difficult to see, but there's a resistor right here, right? Resistor right here. There's a resistor right here, and there's a resistor right here. Now, this is a 100 ohm resistor. Oh no, I'm sorry. This is a 330 ohm resistor. This is a 100 ohm resistor, and this back here is the 220 ohm resistor. Okay, and I've got two breaks in the circuit, one right here, right? And I've got a battery pack down here, which is going to be connected to the two leads, one with the resistor and one with the wire here. And then the other break is down here. And this battery pack is going to be, that battery pack right there is going to be connected to those. So this Kirchhoff's rules is particularly applicable when you have multiple voltage sources and multiple loops, okay? And that's what we want to examine today, right? Now, with the equipment that you bought, it is not terribly conducive or easy to measure the currents directly through the circuit. It can be done, but it gets a little convoluted without shorter leads on your multimeter that would then make it easier to clamp down. So what we're going to do is we're going to connect the circuit and we're going to measure the voltage across each resistor and then use Ohm's law to measure the current through that resistor and then compare that to our theoretical calculation. Okay? Now, the circuit diagram that will be on Blackboard is going to mirror this one. So what you've got is, what you will need is 4 batteries in a row that will then attach to the loop where the 300 ohm resistor is. And then you need 3 batteries for the top part of the circuit, and those will be connected to the 200 ohm resistor and the other wire lead up here. Okay. Now, also notice the orientation. Now, this will be explicit on the diagram, but my positive end is here. So the positive end of my battery is going to connect to this bottom jumper here, right? And the positive end of this battery pack is also going to connect to this jumper end up here, okay? And that just honestly makes the circuit just a little bit more interesting and, frankly, from your standpoint, a little more difficult to calculate. But that's the point. We want to make sure you understand how Kirchhoff's rules operate. And so, also notice, okay, so these are just your regular jumper cables that I have kind of twisted and tied down so that way your circuit isn't, you know, this long, okay? So these are just your regular gator clips and twisted up and tied off so that way they're a little bit easier to maneuver. Now, there's one more setup thing, and that is when you have a clip that has 2 leads going into it, it can be a little difficult to maneuver that and make sure they stay clamped down. You may want to use electrical tape if you've got it. Otherwise, some of these may slip, but in general, as long as they're touching the metal, then it should work. The other thing is that because our resistances are going to be in the hundreds of ohms and we're only using 6 volts with the battery pack down here and 4.5 volts with the battery pack here, then the amperages are going to be extremely low and you will be able to touch and work with the equipment with impunity. Okay, but that being said, we do want to make sure that you don't take too much current, and that's why we're using these values of resistors. So one of the things you're going to want to do is to measure directly, all right, first of all, the resistances of the resistors, right? So they're labeled 330, 100, and 220, but what are their actual values? So notice, okay, that if I take this resistor, and by the way, I've got my ammeter set, or multimeter set on the 2000 ohm setting down here, right? And that's because if I believe this resistor to be 330, then anything above 200, if I have it on the next setting over, will register a 1 and I won't read anything, so I need to set it on the 2000, right? But I want to make sure that my leads are connected firmly here. And as you can see, 330 nearly on the dot. Okay, that's good. And what about this resistor? And 101 or 100. Very good. And you can finally do this resistor. And 223. Okay, so you're going to want to record your exact values for your resistors. Then you're going to want to measure your battery. So what you can do is, and I don't want to mess this up too much, but I want to put this in the frame, so I'll lay it like this for the moment, right? And you can just slip your positive probe on the positive end of the battery, negative end of the probe on the negative end. We want to switch this to volts. And all right, I'm reading 6.41. 6.4. Okay, so I've got 6.4 volts out of my bottom battery assembly, and I've got .4.81 out of the top assembly. Okay, so you're also going to want to record those values. And now it's time to actually complete the circuit. And so I'm going to take some gator clips, clip them to this battery pack, and clip the other end to the lead of this wire. Then connect the other end of your batteries to this resistor, right? And now at this point, if I put, or I want to leave that on voltage as a matter of fact, now I should be measuring some voltage across this resistor. And in fact I am, right? And the negative sign just means the leads on the wires are flipped. It doesn't mean anything, right? So 4.8 or so volts, maybe 4.8 0.84 would be a good average, right? But so keep that value in mind, right? Because we haven't connected this side of the circuit yet. And so we want to connect the positive end of the batteries to this end of the circuit, and then we'll connect the negative end of the batteries to the 220 ohm resistor. Okay? And now watch what happens to this measurement. Okay? Watch what happens to this measurement. .08. Okay, so that's the voltage going through the 330 ohm resistor. .31 volts across the 100 ohm resistor. All right, and then finally 2.37 volts, or 2.4 volts across the 220 ohm resistor. So then, using Ohm's law, you can calculate what the current is through each of these elements, each of the resistors, and then you can compare that with your calculations using Kirchhoff's rules and confirm or refute that Kirchhoff's rules do in fact describe how the current flows through a multi-loop circuit with various voltage inputs. Okay, so that's the lab, and hopefully you don't have too much trouble setting this one up. If you run into problems, let me know, and I'll try to help you out as much as I can. All right, thanks. Bye.